All right, so let's keep going with what we were talking about last time with arrays. So remember when we were dealing with arrays, we're talking about collections of types. So for instance, if I wanted to create an array, AR capable of holding 10 things, can I make that bigger? Capable of holding 10 elements, I would do that. And that's going to go ahead and give me my memory address. So if I were to print out AR, it's going to give me the memory. Oh, I got to choose the language. It'll give me the memory address where the operating system went and found for me enough land to hold 10 integers. Okay. Now, we might want to go ahead and fill up our array with some stuff. So one of the things I'm going to look at today is random numbers in C++. We haven't done that yet, right? All right, so that's going to start becoming handy for us. All right, so we have a couple of libraries here. We have standard library and then time.h, and I'll talk about these guys as we're going through it. Now, we can certainly go through here and we can fill up our array. We can say AR at bucket 0 is equal to 4, something like that. Or we can even write a loop. I think we did this last time. We said for int a or int I is equal to 0, I is less than, I'll just hard code a 10 for right now. I plus plus, and then I can say something like AR at bucket I is equal to I times 3 or something like that. All right. And then we could go through and we could write another loop. And do something like a C out AR at bucket I. And that would show us the contents of that array. All right, so I filled my array up in that first for loop, then I printed out what was in there, and I just gave myself.
Is it possible to say int AR and then fill in values, or do
you can give it hard-coded values
Yeah.
like this? Yeah. So you could do like 3. Actually, you wouldn't even do it. Well, you could do it like this. You would say something like 3, 4, 5, so
Yeah.
on and so forth. I would say that would be pretty uncommon, but you can.
Okay.
You can give it initial values. All right, but generally you're going to say, hey, give me some space. Let's fill it up with some stuff. And then here's proof that there's stuff in here. So really, this is proof that we have a single variable named AR holding 10 separate things.
Now, would if you did that hard coding, would that add or multiply that by 3, or?
Well, what do you mean would it multiply by 3? If you did your hard coding like this,
Yeah. Would that?
I mean, you'd have to, whatever your hard coding says, you put the values in.
Okay.
It's not doing any magic. I mean, those words are
No,
in conflict.
The 4. So would that add to that, or would it just?
This is a brand new array now. So it no longer has 10 things in it. Now it has 3 things in it.
Okay.
So I would get rid of that. I go through 3 and print them out.
Gotcha.
So now I've said, look, I'm going to create an array. I'm not going to tell you how big it is. I'm just going to say, put this crap in there.
Gotcha.
All right. So you can do that if you want.
Okay.
But generally speaking, we're going to be operating off of create some memory, put stuff at that memory, then use that memory to do something. All right. But now as we have it going right now, this isn't overly interesting if I have, by saying, hey, I'm going to hard code some values in there by saying, well, it's a 0, then it's a 3, then it's a, yada, yada, yada. So that's not going to really get us anywhere. So it might be interesting to be able to generate random numbers in our programs. Okay. And built into C++, into the standard library, go ahead and bring these in here. Oh, I'm still working off of this. So I'll give myself these couple of libraries. So inside of standard library, we have a function called rand. All right. And then I'll explain how we're going to use time.h as well. So you might imagine that time.h has stuff in it to do stuff with time. Right. So what I'm going to do here is we're going to still go to 10. Now we're going to do a setup for our random number thing first. And I should be able to show this to you without doing the setup. I think it's going to work the way I want it to work. I'm going to choose not to do this. Instead, I'm just going to generate a random number. So inside here, instead of saying I times 3, I'm going to say rand. And this is just going to generate a random integer for me. I believe it's in the range of all integers. We'll see here in a second. Yep. So there's a bunch of random integers in the range of integers. It looks like it's in the range of just positive integers, unless I just didn't luck out. All right, so this kind of shows us the issue that I want you to see. So this looks like it's in the range of positive integers. Now notice, let's just look at this very last number. 118, 964, 1421. If I keep running this program over and over again, that's not very random, is it? It's the same number every single time. So yes, it's generating what looks like random numbers, but it's the same random numbers every single time you run your program. That's not overly helpful. And it's because generating random numbers is actually a difficult thing to do inside of computers. They're usually called pseudo random numbers. And it's because true sources of randomness are difficult. It's hard to find true sources of randomness. Now, what we usually do is have an algorithm that generates our random number, and we get our randomness off of seeding that algorithm with some unique value. And that's where that srand things comes in. We are going to seed our random number generator. So before I start using it, I'll go ahead and seed my random number generator with the current time. And usually it's going to be like the time in milliseconds, or something called an epoch. The time in milliseconds since 1970, January 1st, 1970 is usually the thing, but we don't need to worry about this. Just the idea here is that time null is going to give us a value that should be unique every single time we run our program. Okay. So now by only adding that line, I run it, we're going to see we get a different number. Just look at the bottom number each time. We're definitely getting different numbers now. Okay. So now we're having something that we can say is truly random numbers being generated. All right. Now, what do we do with our arrays now? So really the benefit for us with these random numbers is now we can kind of test arrays doing different things and not have to spend a whole lot of time coming up with what values am I going to fill my array with. But right now we have an issue right here where we have this number 10 hard-coded, where if I change this guy to 20, now I got to go and change this guy to 20. Now I could do some things. I could give myself like a global variable or something like that. That is my array size and put that in there. Or show you a couple of things here. Well, we'll just do it beforehand. So now I have an array with 20 elements in it. Well, except only printing out the first 10. But we're going to go ahead and we're going to do cout size of AR. I'll just dump my second loop that is displaying stuff. And we see that the size of AR showed up as 80. Well, what is 80? That's 80 bytes, right? How big is an int? 4 bytes. How many ints are we storing? Well, now we're storing 20, right? So 20 times 4, 80. Okay, so when we're asking the operating system, what is the size of our array? It's going to return for us the total number of bytes associated with that guy. So the size of our array divided by the size of an int should give us the number of elements inside of our array. In C++, you'd have to use one of the newer array libraries, like a vector or a list or something like that. Because old school C++ required that you pass in the, well, an array doesn't know how to report its size. And we actually have evidence of that when we looked at some of the early examples here. When we first started writing our main method, we used to have something that looked like int arg c char pointer argv. This is the number of command line arguments. This is the actual command line arguments. So this is the array. So this guy would have been a char pointer array. You could write it like that too. So this is an array of character pointers, which is effectively an array of strings. This guy says, how many strings are there? Because an array in C++ cannot report its size directly. But we can indirectly get it if we use this syntax for creating our arrays. But I'm going to show you kind of an issue we have here. Now, we might look at this and say, well, this looks a little bit cryptic, right? You can say that looks a little bit cryptic. So maybe what we do is we figured out that math, but maybe we don't want to always have to write that anytime we need our array length. So maybe we go ahead and give ourselves a function that does this. So maybe up top, we write a prototype of function, or even better, if you roll back in time to an older style C++ developer, you might have a library that has a whole bunch of these helper functions that you've written in there that makes your life easier. And then whenever you write some code, you just import your library, then you have access to all those things. But up top here, we're going to say, we'll just write a function called int. We'll call this guy array length. And he'll take in well, we'll call this guy int array length. And he'll take in an int array. So I'll prototype it up there and I'll actually write it down at the bottom. I think that ends up making the code look a little cleaner. So what will this guy do? He's going to return size of AR divided by size of int. So he'll do that math. And then all we need to do here is call our int array length, passing it our array. So I've created a function that takes in an array as a parameter, and he returns the number of elements in that array. Well, not necessarily the number of elements, it returns the number of elements that that array is capable of holding, right? Because when I first built an array, I didn't put anything in there. It wants me to take it in as a pointer. That's it up there. Oh, see, that's actually interesting. Well, because you have to have return in there. Yeah, well, so this is actually interesting is it's returning an 8 here because that is the 8 times that's the size of the memory address. AR holds a memory address, not the place where that guy lives. So if I say star AR, is that going to give me the, that's going to give me the size of the element that lives at bucket 0 of AR. So am I able to put it into a function like this? I really wanted to take that. Yeah, it returns the size of an int pointer. But that's interesting that it does that in there. But it didn't do it out here. Oh, interesting. I want you to pass it a command line argument in this interpreter to get the different size. Well, we're going to say relatively unimportant for us. We can still use the math that we had up here. The issue is that when you're taking in an integer array like this, it's you've lost your ability without a flag you pass to the compiler. You've lost your ability to ask this guy what his size is, which then we're right back to that issue of having main look like this. Here, let me try this real quick. I want to make sure that it doesn't put it into the other mode. Yeah, it doesn't. I'm guessing those are all going to be just as bad. This is probably the latest, greatest version of it. Okay. Not a huge deal. We'll have an example of using arrays passing into functions here soon. So for us here, if we want to get the size of an array, you can do a couple different things. One is you might do a global variable. We have AR size is equal to 20. And then when we build AR, we build it with AR size. Well, obviously that guy's going to have going to print out AR size correctly. So that fills it up with random numbers. If I then write my second function, for int I is equal to 0 or separate loop, AR size, I plus plus, and then we do a C out on AR at bucket I. And I'll take out the size thing here. There's all my values. So what I did in this case is I said, you know what problem are we solving? We're solving this problem. I don't want to have to define an array that has 20 elements in it like that, and then have to put 20 here and have to put 20 here. But then I decide, you know what, my array is actually going to be 25 elements. And now I also have to change it here, and I also have to change it here. That's a problem if we write something and we have to change it multiple times throughout our programs, whatever we're dealing with. So in whatever language we're working with, we have to say, well, what's a solution to this? Well, one solution is I can have a variable. Now, in this case, it doesn't have to be a global variable. In general, you might say global variables are bad, but I can create a local variable here in main. A global variable would be available anywhere in all my functions. This guy's scope only lives in main, so he's born at the beginning of main, and when main finally dies, he ends. And I'll show you an example of this here in a second. All right, but then when I build my array, I can say AR size, AR size, AR size, and now it works for 25. Or if I change my mind, well, actually 20, if I change my mind, I make it 200. I only need to change it in that one place. And now I have 200 random numbers. All right, so we're storing our size in a single location. Now, let's look at this idea of global scopes a little bit, or really variable scopes. So I'm going to create another function here called check scope. And I'll stick with our idea of prototyping up top, writing it down at the bottom, although nothing says that we can't just write it right here. I just think you're going to run into less problems if you always prototype at the top and write it someplace else. That way you don't have to worry about was such and such defined before I needed it. All right, and I'm going to try to do a cout AR size and L. Oh, that's not how you say it in here. All right, so check scope is going to try to output a variable called AR size. AR size was defined inside of main, which means that AR size was born on line 20 here and will die on line 34 when main ends. But it is not accessible inside of this other variable scope that in this function called check scope. So it's going to scream at me and say, hey, this was not declared in the scope. I've never heard of it. Now, if I say, well, I really want him to access that variable, which we should think very closely about, does he need that variable? I could say, well, I'm going to go ahead and I'll make it a global variable. I moved it outside of main, so now I defined that variable so it's accessible anywhere inside this file from this point forward, from line 17 all the way to the end of this file. Now he's heard of AR size. Okay, because he's got all variables resolved to their most local definition. So when I get to this variable called AR size, the first place it's going to look, it's going to say, have I seen it here? Was it defined in here? Did it come in as a parameter? Did I have a local variable called AR size? It's going to say, no, I didn't find it there, but I'm not going to give up hope yet, because I can still jump up here and check in the global scope, which is my next scope up, the next level I have available to me. Go ahead. All the way up in my input. This guy?
Okay, so whenever I think about always the size of my.
That's because I used to have a cout here. And this warning is because I didn't return anything from here yet. Yeah, when I was messing around with the size of thing, I had a cout up there. Now, let me explain this scope thing in a picture inside of Keynote, because scoping rules is pretty important. So variable scopes, this is where can you access a variable. All right, so I'm going to draw some pictures. And what I'm going to do is I'm going to create an example of visual version of the code that we currently have in terms of scopes. So I'm going to have a scope here. This is our global scope. All right. So inside of our global scope in our code right now, we have access to a function called check scope and an AR size. Those two things. Now, inside of this global scope, we now have the scope associated with main. This is main's local scope. Call this guy the global scope. Now, inside of main's local scope, we've defined that variable. Okay. I'll steal main scope. Now, inside of check scope's local scope, we haven't defined anything. Okay, so that is the picture of the scopes that are currently available inside this program. Everything lives inside of this global scope. But notice that check scope and main scope are completely separate scopes. This guy, his parent is not main. His parent is the global scope. Okay, so if I'm inside of check scope here, and I'm trying to output a variable called AR size. And the rule of thumb is that all variables resolve to their most local definition. Well, the first place I'm going to look is inside of check scope scope. So I look in there. Is there a variable called AR size in there? There's not. Okay. So I didn't find it in the most local place. So I'm going to keep looking. So I'm going to bounce up to my next most local scope. This guy lives inside of, his parent is the global scope. Make sense? So his parent is the global scope. So now he's going to say, is there an AR size defined inside of the global scope? There is. So he's going to boil down to that number, which will be 200. Now, what if I had instead put that guy inside of main? And we'll go make the code line up with that. I'll steal this. And we'll put it inside of main. Okay. So now this variable was born inside of main. He is a local variable of main scope. So now inside of check scope, when I try to output the value of AR size, it's going to say, well, do I have a local variable called AR size? We do not. Then he's going to check his next more global environment, which is his parent, which happens to be the global environment in this case. And he's going to say, did I find a variable up here called AR size? Nope. So it's going to be an error because global doesn't have a parent. That's the top of the line. And that's why the code as of right now is going to have an error saying, I've never heard of this variable. It wasn't defined inside the scope. Right, makes some sense? Okay, now let's take this a little bit further. Give myself a little bit more space here for main because I'm going to add some stuff. Right now, we're showing the places where scopes can be born. So we have this global scope, which all programs get. And we have this general rule of thumb that global variables are bad. So one thing we want to kind of be careful of as a programmer is only use a global variable when it actually makes sense. And I'll try to give us some examples of that here in a few minutes. So only if you're backed into a corner and the only way to accomplish something is through a global variable, should you use a global variable. Don't use it just out of convenience. You've all run into this probably up to this point when you've been working on homework assignments and things like that, when you've been staring at it for hours and all of a sudden just decide, well, this works, so I'm happy with it. Right? Just because something works doesn't mean that you did it the way you probably should have done it. Okay, so a good rule of thumb, don't use global variables unless you absolutely have to. In the 250 class, when we start working, we'll actually probably do it a little bit in here too. We're going to be starting with objects here pretty soon. We'll see that sometimes there's an advantage of having global variables that can be accessed across multiple objects. That could be handy, okay? And that's when we start talking about these things called design patterns. All right, but to review this concept of a scope, we see the global scope. We see that every function that we write gets a scope. Do we have anything else right now where new scopes are born? We actually have an example of it inside of main. For loop. For loops generate their own scope. And our evidence is right here. I had a variable named I that lived and died with that for loop scope, which then allowed me to create another variable named I right there. That makes sense? So if I want to draw the picture associated with that, I can come in here and change the color of this guy. So we could say this is our for loop. So we have int I is equal to 0 as our starting variable there. And this is for loop scope. And then we actually have a separate for loop. So in our current program, we actually have 5 scopes. We have the global scope. Inside the global scope, there lives 2 separate scopes, main and check scope. Inside of main, there actually lives 2 scopes that are separate from each other. 2 of those for loops create their own local scope. Okay? Which is why if I use I inside of this scope, it's bound to this variable called I up here. And if I use I inside of this scope, it's bound to this variable I. But if I try to print out I there, it's not going to print out. Let me actually make this guy global again, just so I don't get the bug down below, just for the time being. So I just move this guy back up here to our global scope. So now it's going to scream at us and say, hey, I've never heard of a variable called I. And I can look at this code right here and say, what do you mean? He's right there. He's also right there. He's all over the place. Okay. But that I lived and died with that scope. this I lived and died with that scope. So by the time I got down to this line, I didn't have access to a variable I, because what did it do? All variables resolved to their most local definition. So it said, is there a variable I located in my current scope? What scope are we in right here? We are in main's scope. And we look inside of main scope and we do not see a variable named I in here. So we say, okay, well, I don't have to give up hope yet. Does main have a parent? They do. So I'll check my parent scope. So we'll go to global scope and we see, oh, we don't have a variable named I here. So they would say, okay, well, maybe all hope's not lost. Does this guy have a parent scope? He doesn't. All hope is lost. So we get our error message. But what if up here, I had created an I and set it equal to -14? Now we can all agree that in these two for loops, I will never be the number -14, correct? But when I run this now, we see we get our -14. Because when I output I here, the I it finds is not this I. It's not this I. It's the I that was defined in that scope. All right, that makes some sense. And just so these notes end up being useful, let me. I'll do that. And then I'm going to. Get it any. All right, so here's the sample code that this guy reflects. Okay, otherwise, I'm sure we're going to change that code inside of our compiler here fairly soon. All right, so that makes some sense. Now, generally speaking, let's say we're going to say, I already made the comment that global variables are typically a bad idea. So generally speaking, the only global variables that make sense for us are our prototype functions, because we need those to be accessible throughout the entire program, right? All right, so I'm going to go ahead and I'm going to bring AR size is equal to 40 inside here. I'll go ahead and build my array with AR size. I'll do stuff. I'll fill it up with some random numbers. I'll go ahead and print it out, proving everything's cool. Now, maybe I write a function here called display array. And I want this guy to take in an int array as a parameter. And actually, since it's just going to display something, I'm going to make it a void. We're not going to return a value. His job is to display the contents of an array. So inside of display array, we want to do something like int I is equal to 0. I is less than. Now, we need AR size. We either need to calculate it or we need to have it global. We need to get that value somehow. Okay. Right now, I can go ahead and just to make this work, I'll hard code a 40 in there. And rather than having that loop there, we'll call our display array passing at AR. So I filled my array here with random numbers, and now I want to display it. So I'll call display array. Display array was defined in the global environment. So he'll call it, and this is what display array does. It goes through and does something 40 times that I've just hard coded the 40, and he's going to print out elements of that array. So there's my 40 elements. Okay. But now it might be helpful. Functions we usually want to write generically. So this function right here, he knows how to display any array as long as he knows the size of that array. So I could say int AR size here. I could have this guy require that 2 parameters are sent in. The array itself and how big that array is. Give me both of those values, and then I can write a loop that will work with any array, as long as you give me the array itself and how much stuff is in it. So if I'm up here, I do have access to a variable called AR size. He is a local variable to main. I defined him inside of main scope. So from this guy's perspective, all variables resolve to their most local definition. So AR size, he's going to look here in main's scope and he's going to find, oh, yeah, AR size right there, it's 40. So this guy's going to resolve to 40. AR, well, where was he defined? Oh, he was defined right here. He's going to pass him in. Those 2 parameters are going to come into this guy right here, and it's going to print it out. Now, I just happen to name these parameters the same thing as the variables up there, and that's why I'm using them in here with those names, but nothing said that I couldn't have called this guy LOL and this guy Woot, as long as I make the guys down here match. This function takes in an integer array and takes in an int. I can name them whatever I want here as long as I use them by those names in here. So I'll pass in my array AR and the size AR size, and AR is being passed in is being linked to this variable called LOL, and AR size is being linked to Woot. And you see this guy, whoop, too many arguments. I wrote it there, but I didn't update it up here. And actually an interesting thing up here. Well, this is actually an interesting thing. AR size, I'll write it like that. You'll see this still works. Notice when I prototype this, I had my variables named AR and AR size. But down here, I had them named LOL and Woot, and it still worked. So what does that tell you? It tells you that C++, and this is true for all of our modern languages, they don't care what you name your variables, as long as when you reference them, you're using the names that are currently in the scope. So when C++ read this prototype line, it didn't care about AR and AR size. All it cared about is that I was taking in an int array and I was taking in an int. So when you prototype it, I think you can write an int array like that. Otherwise, we'll just have to pass in a pointer. Yeah. So I can write display array saying he's taking in an integer array and he's taking in an int. I don't even have to name them up there. Why do I have to name them? because I'm not using them yet. I give them an identity down here. I would never write it like this though. I would almost always make the two match. Because more than likely I actually copied and pasted from up here when I wrote it. All right, that makes some sense. All right, so for all intents and purposes right now, since we're using the primitive built-in array type, we need to pass around the size of our array as a parameter to our functions. All right, so in order to work with arrays inside of a function, we need two pieces of information at least: the array and how big it is. And depending on what you're doing inside the function, you potentially might need some other inputs, but you at least need those two. So homework. Write a function that takes an array and its length as parameters and returns a new array that is the original in reverse. Test your code by displaying both arrays using a display function. Well, I'll just say displaying both arrays. You can do whatever you want. Presumably, you'll display it using the same thing we did here. We wrote display array that knows how to take both. Okay. And I'll go ahead and save this and give you a link to the current code. All right, questions, what I'm asking you to do for Tuesday? Go ahead.
Not the PowerPoint, but it's not on share.
This PowerPoint's not, it says collaborate. There's people joined into it.
I couldn't see it. Oh, maybe it's because we changed the.
Here, I'll just paste the current link inside of 200's thing. That's the PowerPoint slides.
Okay. Yeah.
All right. Questions, comments, concerns, bribes. All right, I'll see everybody on Tuesday. And remember, for some reason you couldn't get the quiz in, make sure you submit it to the to Blackboard by midnight tonight if you had problems, but it seemed like it was working, but just in case.